In this lesson, we're really going to be looking at erosion in groundwater systems, which basically means we're looking at caves and how groundwater basically works together to help erode the land and as well as shape the land. And when we think about the way the erosion takes place, a lot of times we think about it as the abrasion part, where the water is literally running over the soils and then pushing the dirt away. And that's really, when we think about groundwater erosion, it's actually not that common. The most common type is dissolution. Now, what does that mean? Yeah, it's dissolving. So basically, when we think about erosion, the most common way that things are eroded is actually by dissolving the material. And when we think about the way that this happens, it's typically looking at limestone. Remember that from earlier this year, we were talking about limestone was CaCl3, calcium carbonate. If you guys remember, that's when we took the hydrochloric acid, put a little bit on the rock, and started to bubble. You guys remember doing that?
Yeah.
All right. Water does something very similar. It takes a lot longer to take place, but it does the same exact thing. It's going to dissolve away the limestone, and it releases carbon dioxide as a gas. But then it has this calcium left over, and that's actually, you see the things dripping down from the ceiling? Those are calcium deposits. So as the limestone is being eroded and being dissolved, the calcium ions group themselves together and they create these spires that come up off the floor, and they also drip down from the ceiling, and that's basically just pure calcium. And so when we think about this, mostly with limestone, it creates two types of features. One of these we've already talked about, the karst topography, right? We talked about that earlier today and what that means. Anywhere where you have a lot of limestone is being dissolved away, you have openings under the ground, it's going to create karst topography. And part of that karst topography is caves. So if you live in a region that has a lot of caves, it's going to be a karst topography. In fact, there are really cool places around the world where humans have made shelters out of the karst topography. And I know a lot of you guys are like, okay, like, duh, cavemen. Also, there's really no such thing as cavemen, Neanderthals, really. And they lived in the caves. But that's not really what I'm talking about here. I'm talking about modern humans that live in caves. And there are places in Turkey, the actual country Turkey, the city. And it's actually really neat. Turkey is, again, it's a very common place where you get a lot of karst topography. And what humans have done over the eons is actually built homes in the rock. And then each of the homes are connected by these small little channels. And now they've got to the point where from the far distance, all you see is this rock outcrop. And then there's a satellite dish sitting on top of it. So yes, they have internet. They have satellite TV to watch. They have electricity. But they should live in caves. It's kind of neat. What's the benefit of living in a cave? It's always cool. All right, one of the neat things, if you guys ever get a chance to go visit a cave within the United States or anywhere, it's really neat. Take the tour.
Turkey.
Turkey.
So, yeah, we'll take you to Turkey. It's a great idea. What?
No.
Okay, we're moving forward. All right, so the inside temperature of a cave is constant. It never fluctuates. Even from season to season, it's the same exact temperature all the time. And when we think about most caves, it hovers right around 55 to 60 degrees. And it's that way every day, all night, it never changes. So it's kind of neat to have that. So that's a big benefit for people who live in caves. It's a nice way to actually keep your house, keep your home cool. And you don't really need to heat it that much. But again, the rock's a huge insulator. And so even if you do heat it, it's going to keep that heat a lot longer. So some benefits there. So we look at caves. What is a cave?
Hole.
How the hole get there?
By earthquake and tornadoes.
Guys, how did you make your cave?
Oh, the ask
We use a
the
pickaxe. We have diamonds.
Now, think about it. How did we make our caves yesterday?
water
It wasn't an earthquake. What did the water do?
You wrote it.
It dissolved the sugar, right? What did the sugar represent?
limestone.
The limestone. So caves are formed when rock is dissolved away, and it's basically just an open area under the ground. So the basic definition is very simple. It's a natural underground opening with a connection to Earth's surface. That's a cave. Now that connection might be a very long way away from where the actual cave is, but it still is going to have a connection to the surface. Otherwise we'd have no clue it exists. And I say, no, this shouldn't be usually. They will develop in the zone of saturation. And remember, this is one of the things we talked about yesterday. Why does that clay ball have to be submerged? What would happen to that sugar cube if it wasn't completely submerged? It wouldn't dissolve all the way. So therefore, the only way for a cave to actually be created is if the limestone is in the zone of saturation. That water needs to be there to be able to dissolve away the limestone. So it actually needs to be below the water table. Now at some point that water table is going to drop. And when it drops, it's no longer filled with water. So what's it filled with? Over there, we now have a cave. That's the process. You have solid limestone, water gets into the cracks of the limestone, slowly dissolves away, creating larger and larger cavities filled with water. And when the water table drops, you're left with the open cavity. And that's basically how our caves are formed. By the way, that will be a test question. Explain to me how a cave is formed. So water dissolves, that's the first step. Water dissolves the limestone, creating larger cavities. And then the water table drops, and we're left with an open air cavity, thus the cave. So let's actually see this in motion. So now what we're actually seeing right here, as we start off with natural cracks in the limestone, the water is getting into the limestone area, all of this is limestone. And as we move forward, okay, the water as it dissolves is basically creating larger and larger cavities. Notice our water table, right here, level with the stream. And then the water table drops, and what are we left with?
Cave.
Lots of caves. Really, really simple. All right, so tell me some places around here. Where have we seen caves? I know I already told you guys about Marengo Cave. And you guys said Turkey Run. Okay, what else? I know like far southern Indiana has some. I don't think you're gonna get any this far north.
Michigan.
I have no idea. Have you guys ever traveled down to Kentucky? I think it's Kentucky has Mammoth Cave. Is that in Tennessee?
I think that's in Tennessee.
Is that Tennessee?
Yeah.
So there's a lot of places you guys go. They're fairly close, and at least an easy day's drive. No. No. Yeah, that's great. This thing? Okay.
Wait, how does it resemble honeycomb?
You ever eat a honeycomb cereal?
Yeah. That's amazing.
There's all these little holes in the honeycomb.
Yeah.
Ignore the holes. Okay. Imagine filling this with some type of epoxy, plastic, rubber, etc. Okay, and then dissolving away all the limestone. Okay, and then look at what you would have is this 3D winding thing where all these open areas are connected. That's what we're talking about the honeycomb. So when you think about the honeycomb cereal, the actual cereal piece, think of those as little passageways that are all connected. That's the honeycomb.
Interesting.
If you guys ever saw a volcano,
Do they ever make honeycombs anymore?
yes.
Yeah.
I think it's volcano, right? Is that the one with oh come on, Tommy Lee Jones?
What?
Yeah, I've seen that.
Yeah. And then it gets like really stupid, and so they had these gigantic cracks, and someone's big idea is let's fill in the. Basically, they want to fill in the cave ends, so they actually get this epoxy that you normally would use for insulation in your home. It's the spray stuff that like expands, and then they pump it into the caves. That's supposedly going to keep it from falling in. I mean, was that not okay? So it was. So, I think it was on Sci-Fi Channel. So you know,
Dude,
they have
Sci-Fi
stupid
Channel's
movies
a lie.
on
We
there.
watched it on really dumb.
It was not Nova.
It was not volcano.
That wasn't Volcano?
No, they
Volcanoes
knocked
were the
down
one they
the
actually used.
building.
That's right, they knocked out the building, it had like the cement.
Yeah, because they
Yeah.
needed to channel it, so they blew up the street and took down the building to,
Because that'll stop the lava.
no, because the one, they made a huge freaking channel for it, but, it's within a sewer system.
Yeah.
So they blew all the street up because
Ah.
it wouldn't hit that stop wall and it would have came straight up and been really, really bad. So they took down the building with it to.
You know what they really needed? They needed Aang to come in and divert everything and save the city.
Well, they had to think that because the hospital